All right, so today we are still focusing on bisectors. Okay, so we're still focusing on the angle bisectors and the perpendicular bisectors, but we're going to talk about today what happens when all three of them intersect at the same time. So if I have three sides of a triangle, then that means there are three perpendicular bisectors. If there are three angles in a triangle, then that means there are three angle bisectors. So what happens when three perpendicular bisectors intersect? What happens when three angle bisectors intersect? So what we're going to do is we're going to identify the points of concurrency, which is a new term. And then we're going to find the circumcenter and the incenter, which are both new terms. So concurrent lines. So concurrent lines are when three or more lines, rays, or segments intersect at the same point. Think about when streets intersect. Okay. Usually when there's an intersection, there's a stop sign. Stop signs are placed at points of concurrency. Okay. So a point of concurrency is the point of intersection. So concurrent lines, when three or more lines intersect, they intersect at the point of concurrency. So here is a picture example. So I have lines A, B, and C. They are concurrent because they all intersect at point P, and point P is called your point of concurrency. Okay? Basic, simple, to the point. All right? So now, just like yesterday or last class, I gave you 4 pictures. I introduced all 4 things to you. We focused on 2. I'm doing the same thing today. I'm going to introduce all 4 options, and we're going to focus on 2. So first of all, we have what's called a circumcenter. A circumcenter is formed by the intersection of your perpendicular bisectors. Okay, so your circumcenter is formed by perpendicular bisectors. And if you look at the picture, you can see that there are perpendicular bisectors here. So if I find the midpoint and I draw a perpendicular line, find the midpoint, draw a perpendicular line, find the midpoint, perpendicular line. They intersect at point P. Now, let me tell you why it's called a circumcenter, okay? It is a circumcenter because it is the center of a circle. But where's the circle? I don't see one. That's because the circle actually goes around. This is a terrible circle. It goes around the outside of your triangle. We're going to pretend that's a pretty circle. Okay, so this is the center of the circle that goes around the outside. A better example would be if I were to draw a circle and then drew a triangle in here. The center of the circle, triangle, circle. Okay. Now, if you'll notice, there are these extra lines in here. Okay, those extra lines, if you think about it, those are the radius of the circle. What do we know about the radius of a circle? We know that the radius of a circle are all equal. Okay, so that means that all of these yellow lines here are all equal to each other because they're the radius. So that's the radius of the circle, that's the radius, and that's the radius. They just so happen to go through the corners of your triangle. Okay, and there's a special property. We will get to that in a minute. Okay, I'm pointing out all the stuff right now. Now the next thing we have, this is called an incenter. Incenters are formed by your angle bisectors. So if I draw an angle bisector, so I'm going to draw this angle bisector. So this angle is equal to this one. I'm going to draw this angle bisector. And I'm going to draw this angle bisector. They all intersect at point P. Now point P is called the incenter because now there's a circle on the inside. And now all of these yellow lines are equal to each other. And they're also perpendicular. They're not at a midpoint or anything. They're just perpendicular and equal because those are the radius of the inside circle. And again, special properties we'll get to in the next part. Now, these two we're going to talk about next time. So we have a centroid, okay? So we have a centroid, and the centroid is formed by your medians. Remember, your medians are what connects midpoints. So if I were to draw all my medians, vertex to midpoint, vertex to midpoint, vertex to midpoint, they intersect here. This triangle at the centroid, that is the center of gravity. Okay, if I wanted to, if I could get that accurate, I could balance it on the tip of my pen because it's the center of gravity and it would balance flat at that point. So it's kind of cool if you're kind of like into that stuff. I think it's pretty neat. And then the last thing, this is our Ortho Center. Our Ortho Center are formed by your altitudes. And there are no special properties that go with this one, just that your heights all intersect at the Ortho Center. Okay, so now not only do you have to remember bisectors and medians and altitudes, now you have to remember the names of the points where they intersect. Okay, so I'm going to show y'all this little trick. It's really cheesy. So perpendicular bisectors intersect at circumcenters. Angle bisectors intersect at incenters. Medians intersect at centroids, and altitudes intersect at orthocenters. Pretty cats are inside, mean cats are outside. Has nothing to do with geometry, but it is a sentence that kind of makes sense to help you remember which two letters go together. So you got your perpendicular circumcenters, your angle incenter, your median centroid, which those two kind of sound the same because you think median, middle, center, centroid. So those two kind of go together. And then altitude and orthocenter. I think of altitude like altitude. I associate it, and this is really cheesy also. I associate the altitude when I go to the orthodontist and they give you gas and you get kind of high. Altitude, height, ortho. So I kind of use those to pair together. I've always come up with things that make me click things together that have nothing to do with the actual topic. But it works. Just whatever can make you connect things to help you remember which two things go together. You could come up with your own little saying. There's other sayings that I've heard, but the pretty cat one is the one I've remembered the most. Okay. Now we're going to look at these pictures because now we're going to do just like we did last time where we actually look at the tick marks and decide which one is it, which is which. Okay. So this is a picture of, so what I noticed right away is I have these two tick marks. So that means this is a midpoint. If that is a midpoint, then this is a median. Since those are medians, that makes this a centroid. So this is a centroid. So I go up here, centroid is A. The next picture, I see just straight perpendicular lines. No midpoints, no nothing. So that makes this an orthocenter, which is created by altitudes. So orthocenter is B. In this picture, I see midpoints because I see the matching tick marks here. So I see midpoints and 90-degree angles. So that makes this a circumcenter. So these are my perpendicular bisectors. So the circumcenter is C. And then I see the angle tick marks. So that tells me that this is going to be right here. This is going to be an end center, which is created by my angle bisectors. So this is D. All right. So now all right, so first we're going to talk about the circumcenter, all right? So the circumcenter is equidistant. So it is an equidistant distance. That is a typo. So it is an equidistant from the vertices, okay? So if I go to my circumcenter, it is equidistant to all of the vertices. Well, remember in my picture, I said it just so happens that the corners of the triangle lie on the circumference of the circle, making all of these the same. So all of these are equidistant because they are the radius of the circle. So in this picture, if PD, PE, and PF are my perpendicular bisectors, then PA, PB, and PC are all equal to each other because they are the radius of the exterior circle. So I'm going to write that on the side here. These are the radius of exterior circle. And then maybe make myself another lopsided circle so that I can remember. So now it says point P is the circumcenter. So point P is my circumcenter. Well, if it's my circumcenter, that means all of these segments are equal to each other. So that's what, when I do these problems, that's like the first thing I do. As soon as I know what I'm dealing with, I automatically go to what's equal then. So these three things are equal. So what is the length of PA? Well, PA is the same thing as PB. PC is the same thing as PB. So they're all 13. There's no math that needs to be done if they give you the actual number, okay? Now, please keep in mind, because these kind of questions will come up, that you do have some right triangles going on in here. And if they had given me a little more information, like maybe they told me this was 12. Well, if they told me that was 12, then I could do Pythagorean theorem and find out that this is 5. Okay? So you will be able to use other things to find missing pieces if needed. If not, then you just go with what they give you and know that they're congruent. Okay? Same thing over here. Point P. Please note, when you have an obtuse triangle, your circumcenter is outside the triangle. Okay? So make a note. Obtuse triangle, circumcenter is on the exterior. Okay, so if you have an acute triangle, it's on the inside. And if you have an obtuse triangle, it's on the outside. And when you have a right triangle, it's somewhere else. And I'll show you that in a second. So if PE is this, that's going to one vertex. PD goes to the other vertex. And PE goes to the third vertex. So what do I know about these three segments? They're all congruent, guys. It doesn't matter if it's on the outside or the inside. The rule is the same, okay? The segments that connect the circumcenter to the vertex will always be the same as long as you have the circumcenter. So I know that all of my circumcenters are 10. So basically, the circumcenter looks like it could possibly be the tip of a pyramid. Do you see it? Okay. Now, this next part here says, find the coordinates of the circumcenter of a triangle with these given vertices. So I'm going to plot these 3 points, but first I got to figure out where exactly I want my axis to be, because it just gave me a blank. So since the smallest x value I have is -2, I'm going to make this line be -2. This is -1, so this will be 0, which will be my y-axis. Does that make sense? And then my smallest y value is -2. So this line down here is -2, -1, 0. So this will be my x-axis. So now when I plot these points, so -2, -2 goes here. So that's point A. -2, 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6, 1, 2, 3, 4 is point C. So now I have a right triangle. So you're getting to see an example of each. So you got an acute, an obtuse, and a right triangle. So where is the circumcenter on a right triangle? We know it's on the inside of an acute triangle. We know it's obtuse, it's on the outside. So for a right triangle, where's it going to be? Well, it has to be a perpendicular bisector. So I'm going to find the midpoint of each one of my sides. So the 2 flat sides are the easy ones. So 1, 2, 3, 4, 5, 6, 7, 8. So since this has a length of 8, halfway would be 4. So 1, 2, 3, 4. So here's the midpoint, and then I'm going to draw a perpendicular line. This is equal to this. So now I'm going to do the same thing here. This is 1, 2, 3, 4, 5, 6. So since this has a length of 6, halfway would be 3. So 1, 2, 3. So there's a midpoint there. So I'm going to draw a perpendicular line. This piece is equal to this piece. Do you see where these two are intersecting? That is your circumcenter. You only have to have 2 because the third one will automatically intersect. So that means the distance from here to this corner, oops, and to this corner here, these are all the same length. And notice where this is located. This is the midpoint of your hypotenuse. Okay, so think about acute, your circumcenter is inside. Obtuse, your circumcenter is outside. When it's a right triangle, the circumcenter is the midpoint of the hypotenuse. And this only works on right triangles. So the circumcenter is the midpoint of the hypotenuse. So in a right triangle, the circumcenter is the midpoint of the hypotenuse. Those are your 4 key things for that one. So where is that located? Because it says find the coordinates of the circumcenter. So 1, 2, 1. So my circumcenter is 2, 1. So knowing this right here, knowing this piece of information, when it asks you for the circumcenter of a right triangle, all you have to do is find the midpoint of the hypotenuse, and you're done. We've been doing midpoint since the first week of school. Okay? Questions? All right, so let's do the end center. 2 more examples, and then you can get started on your assignment. So in the end center, all right, so the end center, this is equidistant to the sides, which is what I talked about over here. Whenever I highlighted these yellow, I said it's equidistant to the sides, so it's the same thing. So now I know that if AP is an angle bisector, BP is an angle bisector, and CP is an angle bisector. Point P is the end center. Therefore, PD, PE, and PF are all going to be equidistant to the sides. So PD, PE, and PF. And don't forget, there is a circle on the inside that makes that work. So now, knowing that, N is the end center on both of these questions here. If ND is 2x minus 5 and NE is negative 2x plus 7, I know these two are equal. Find NF, which is also going to be equal. So I need to find x and plug it in. And if you know one, you know all three. So 2x minus 5, negative 2x plus 7. So I'm going to add 2x to both sides. So I get 4x minus 5 equals 7. Add 5 to both sides. 4x equals 12. Therefore, x is 3. Well, if x is 3, then I'm going to plug it in. So ND is 2x minus 5. So that means 2 times 3 minus 5, which is 1. So all of these have a length of 1. NF is 1. So we're going to do it one more time. This time it tells me ND is 5x minus 1. NE is 2x plus 11, and it says to find NF again. Well, remember, these three are all equal to each other. So I'm going to 5x minus 1 is equal to 2x plus 11. So if I subtract 2x, three x minus 1 equals 11. Add 1. 3x equals 12. So that makes x 4. So if x is 4, ND is 5 times 4 minus 1, which is 19. So if ND is 19, then NF is also 19. So the next part is taking it one step further, and it says, can NG be 18? So the first time I ever looked at this problem, I was like, well, I don't know. How do I figure that out? And then I had to think, okay, back up, think about the tick marks that you see in the picture. What are the things you recognize? Because that's the whole point of geometry. So first thing I see is that NFG make a right triangle. So here's N, F, and G. And I know this is 19. So as soon as I saw it like that, I thought, well, no, this cannot be 18 because it's the hypotenuse. And the hypotenuse has to be the longest side. So that means the hypotenuse has to be greater than 19 for this to work. So no, NG has to be greater than 19 because it is a hypotenuse. And the hypotenuse is the longest side. So make sure when it asks you to explain that your explanation is valid. You can't ever say because that's not valid. You don't accept it because when your mom says it, right? You say, I want to do something. And she says, no. When you say why, she says, because. Just makes you mad.